What is a thread? In computer science, a thread of execution is the smallest sequence of program instructions that can be managed independently by a scheduler, which is typically a part of operating system. So, these are the basic threading issues. Fork and execution system calls, thread cancellation, signal handling, thread pool, thread specific data, and scheduler activation. So, let us learn briefly about one by one. So, first comes the fork and execution system calls. So, let us know what is meant by fork. The purpose of fork is to create a new process, which becomes child process of the caller. After a new child process created, both processes will execute the next instruction following the fork system call. Therefore, we have to distinguish the parent from the child. Execution is the functionality of an operating system to transfer an executable file in the context of already existing process, replacing the previous executable. So these are the functions of the fork and execution system calls. And next comes thread cancellation. So what is the thread cancellation? Basically, it is the task of terminating the thread before it has completed. A thread that is to be cancelled is often referred to as the target thread. Cancellation of the target thread may occur in two different scenarios. So one is asynchronous cancellation, the other is deferred cancellation. So coming to the asynchronous cancellation, one thread immediately terminates the target thread. And deferred cancellation, the target thread periodically checks whether it should terminate, allowing it an opportunity to terminate itself in an orderly fashion. Next comes the signal handling. A signal is used in Unix systems to notify a process that a particular event has occurred. In general, the following options exist. Deliver the signal to the thread to which the signal applies. Assign a specific thread to receive all signals for the process. Types. Every signal has a default signal handler that is run by the kernel when handling that signal. This default action can be overridden by user-defined signal handler that is called a handler to signal. And next comes thread pooling. So, the general idea behind a thread pool is to create a number of threads at process startup and place them into a pool where they sit and wait for work. Thread pools offer these benefits. Servicing a request with an existing thread is usually faster than waiting to create a thread. A thread pool limits the number of threads that exist at any one point. This is particularly important on systems that can't support a large number of concurrent threads. So this is about thread pooling. And next comes thread specific data. Threads belonging to a process share the data of the process. Indeed, the sharing of data provides one of the benefits of multi-threaded programming. However, in some circumstances, each thread might need its own copy of certain data. We will call such data thread-specific data. For example, in a transaction processing system, we might service each transaction in a separate thread. Furthermore, each transaction might be assigned a unique identifier. To associate each thread with its unique identifier, we could use thread-specific data. This is the purpose of thread-specific data. And coming to the scheduler activation, it is a final issue to be considered with multi-threaded program consoles communication between the kernel and thread library, which may be required by many-to-many or two-level models. Such coordination allows the number of kernel threads to be dynamically adjusted to help ensure the best performance. This can be achieved with the help of scheduler activation. So this is all about threading issues.